All right, guys, we are going to look at 8.2. This is the one where it can get a little tricky because we are doing the math side of things here. All right, so once again, if you are struggling, you have any questions, let me know. But remember, this worksheet today is participation. So just try. And I'll ask too, because I know that 7.5 was a little rough and it had these conversions on it. A lot of you just gave me answers and I couldn't see, like, were they starting to set this up right? Where did it go wrong? So try to show me your work so I can see what happened and what went wrong. Remember, it's like, I understand, like, this is going to be tough. You guys trying to learn this and do this without the teacher there to help you. So I know that. So let's just try to do the best we can. All right, so calculations, using calculations with what we just did in section 1. I asked you a few questions right here, just trying to get you guys to see where these numbers are coming from. So how many moles of Fe2O3 can form when I have 3 moles of oxygen? So when I have 3 moles of oxygen, I can form 2 moles of Fe2O3. So then I'll ask you guys, and a lot of kids get this, or several do anyway, how many moles of Fe2O3 can form if I change this from a 3 to a 6? So I doubled this. So a lot of kids know that if I doubled this, then I'm going to double that also. So they will then say 4 moles of Fe2O3. Then I'll say, okay, well, how many grams is that? And what I should have done here is I should have asked you up here, how many grams is this? If I were to add up this, there's really 4 irons, which would be, iron is 56, if you round up, it's 56. So 224 grams for iron. Oxygen, there are 6 of them, so that would be 96 grams. So altogether, this would be 320. All right, so when I have 2 moles of this thing, it's 320 grams. Now, if I change this to 4 moles, I've doubled. I'm just going to double this amount. So now that would be 640 grams. All right, there probably could have been an easier one, maybe with just hydrogen and oxygen to see this. But I wanted to get something that had some different numbers in there. All right, so how did I figure out number 2? Well, I told you that I doubled, so I was going to double again. Well, if you're doubling, you're multiplying, right? So what type of math did I do? I multiplied. All right, I took 3 and I doubled it. I'm sorry, I didn't take 3, I took 2. I took my 2 moles here and I doubled it, and that's how I knew this was going to be 4. So to do the math side of things, because it's not always, oh, we're doubling something. Sometimes it's like, I want a fifth, or I want 0.7238 moles of something, or I want 120 moles, and it's a lot harder than just doubling. So we need to know what kind of math we're going to do. So if I were setting this up and they said, okay, you have 6 moles of O2, how many moles of Fe2O3 can you get from that? Well, that goes with, remember yesterday during section 1, I kept telling you, you're going to use a conversion and it's going to depend on what they give you right here. Well, that's what I'm doing here. I know that moles of O2 have to go on bottom, and what I'm looking for is going to go on top. Now, these numbers that you guys got yesterday to plug in here, you got them right here. You got them from your equation. So if you need to look back at the front page of your notes, we did this yesterday. So moles of O2 are 3. Moles of Fe2O3 are 2. So then I'm going to take 6 times 2, and that is 12. I'm going to divide that by 3, and that will give me 4, which is what I got up there. Like I said, they're not always these neat numbers of just doubling, though, but this is how you would go about solving that problem. All right, so 4 moles. So let's do a learning check with this then. I'm going to erase this. Once again, you guys can always pause and kind of do some things and come back. If I'm going a little too quickly, just pause it or go back. The learning check says how many moles of iron are needed to react with 12 moles of oxygen? Well, I always start my math problem out by writing down what they give me. And they give me 12 moles of O2. So I'm going to put my moles of O2 down here. And what am I looking for? I'm looking for moles of iron. So I'm going to put that on top. Now I use my equation just like we did yesterday in section 1. I use that equation to write these conversion factors, or the mole-to-mole factors they call them. So I've got 3 moles of oxygen and iron is 4. So I'm going to take 12 times 4 divided by 3, and that should give you 16 moles of iron. So now we're going to take it a step further, because that's what they're going to do on the questions here. This is just like, oh, that's how many moles. Okay, well then how much does 16 moles of iron weigh? Because sometimes, especially if we get to finally do a lab in here, because we would have done some labs last week, if we can finally do a lab in here, you don't count by moles. Like, that's hard. What I have you guys do is I have you weigh using the scale, so you need to know how many grams. All right, so I know that 1 mole of iron is 56 grams, so I need to know how many moles then are in 16. Well, if 1 mole weighs 56, then I just need to take 16 times 56, and that is 896 grams. All right, so if I gave you guys some iron, which I have iron filings back here, and I told you, measure me out 16 moles, you guys would have to go out there and you'd have to measure 896 grams of that. And you'd be like, here's 16 moles of iron. All right, so but we multiplied here. All right, so let's do another learning check. Now this one will take both of these and now combine them into one step. All right, so let's look at how to do that. So it's not as messy, it's not taking up as much room. So here's what I'm doing. I'm always looking for what do they give me. And they give me 0.400 moles of iron oxide, so that's what I'm going to write down. I always write down what they give me. Then I'm going to look at, okay, what are they asking for? They're asking for grams of oxygen. Okay, so if you remember the question we just did, the first step we did was change from moles of iron oxide, and we changed into moles of oxygen. All right, in order for me to figure out how many grams of oxygen, I got to first figure out how many moles there are. So using my equation, I can see that 2 moles of this, there's 3 moles of oxygen. All right, so right now, if I were to solve this, my answer would be in moles of oxygen, but I want grams. So I'm going to do that second problem that second step that we just did. So right now, this cancels out. I need moles of oxygen on bottom. And I know that oxygen, I'm going to have grams, that's what I'm looking for. Oxygen weighs 16, but there are 2 of them. So there's going to be 32 grams in 1 mole. It is always 1 mole weighs this. If you want to tell me how much 2 moles weigh, then you're going to have to double that to 64. I've had kids do that in the past. I'm like, you're doing extra steps you don't need to do. Just 1 mole weighs how much? Use your periodic table. All right, so now I'm going to take 0.4 and I'm going to multiply by 3. Divide by 2 and multiply by 32, and you get 19.2 grams of oxygen. So if we needed to do this, and if you had to weigh that out, you could. And we can't in here, we don't have the capabilities to weigh oxygen, but that's how you would do that. All right, so let's do this last learning check. This is going to be the longest type of problem that you can have. So I'm going to write something down, and you guys can put this on your periodic table. All right, so first I'm going to read the question. We're going to figure out our game plan, and then I'm going to write out like a little guide for you guys. So acetylene gas is C2H2, and it burns in oxyacetylene torch for welding. How many grams of C2H? So this is what I am looking for. Grams of C2H2 are burned if the reaction produces, now this is what I am given, this is what I'm going to write down, 75 grams of CO2. All right, so I'm going to go ahead and write that down. But my game plan is, okay, I've got grams of CO2 and I need to get grams of C2H2. We have not done that yet. We have went from moles to grams, but now we have to go from grams to grams. So we're getting like this third step in there. So this is what I will have you guys write down on your periodic table. So I'm going to have grams. This is the first step I'm going to do. I'm going to go from grams of whatever they give me, number 1, which is CO2. I'm going to go to moles of number 1, which is CO2. So my first step is going to be going from grams of the first element they give me to moles of the first element they give me. So let's go ahead and write that CO2 on the bottom, and I'm going to moles of CO2. So you can see where this is my first and my first. That's why I put that one right there and that one right there. Now, how to get these numbers? Anytime you see grams, you are getting that from your periodic table. So CO2, I've got carbon that weighs 12, I have an oxygen that weighs 16, but there are two of them, so that is 44 grams. This is always 1. So this is always going to be a 1 right there. All right, so now my next step is to go from moles of number 1. I need to switch it over to whatever I'm looking to, because you see CO2 is different than C2H2. So I need to go to moles of my second substance. All right, so that's going to be my second step here. So these have canceled out. I'm going to put moles of CO2 on bottom so they can cancel out. And I'm going to switch over to moles of this second substance, which is C2H2. Now when I do this, I am going to use the equation to get my numbers. So up here, and this is what we've been doing since section 1, using that equation to get these numbers. Moles of CO2 are 4, C2H2 is 2. All right, so these cancel out. If I were to quit right now, my answer would be in moles of C2H2 with that acetylene gas, but I want grams. So this third step, moles back to grams of that second substance, because I'm now in my new substance, that second one. Just like the first part of this, when I'm doing moles to grams, moles are always 1, and I'm always using the periodic table to get to that grams. So let's do that third step. I'm going to put moles of C2H2 down here so it can cancel out. I'm going to put grams of C2H2. Once again, I said it's always 1 mole. Now carbon is 12, but there are 2 of them, so that's 24. Plus hydrogen is 1, but there are 2 of them. So that is going to be 26. This cancels out. It leaves you with grams of the acetylene, which is what they are asking for. I'm going to take 75 divided by 44, multiply by 2, divide by 4, multiply by 26, and that is 22.2 grams of C2H2. All right, people do this so that they can measure things out and see how much you're making. And this is why I said we need to learn how to set them up this way, because it's not always just doubling. I mean, this didn't double. If it were doubling things or tripling, like that stuff we can do. We know, oh, multiply by 2, multiply by 3, but when they give us weird numbers, we need to know how to set them up and if we're going to multiply or divide. All right, so that is some examples of this. Make sure, because if you get back to school and we're doing tests back in the classroom, you guys can have that periodic table out, and that can be on there, and that will help you out as a guide. So make sure you've written that down. If you have your periodic table with you, write that down on there, on the back or wherever. All right, once again, if you need anything, let me know. I will help you out with whatever you need. We'll get through that. Have a great weekend, and I will see you guys later.